welcome to the House of zk Radio, which is a focused podcast and media channel exploring everything zk, zero knowledge. Hi everyone, welcome to the House of zk Radio podcast. My name is Alice, I'm the primary host at the podcast. I'm joined here today with Orkun, who's co-founder of Citrea. Really excited to have you today here. Orkun, Thank you so much for joining.
Yeah, thank you for inviting me.
Yeah, thank you. And I'm wondering if we can first start off with an introduction of yourself, maybe how you got involved in the Web3 and specifically focused in the zk spaces.
Yeah, so I'm an engineer with my background. So I was doing web development for years since my high school times, basically. But during college days, I discovered blockchains and smart contracts through real life use cases that people send money to each other. I'm from Istanbul, Turkey. So we have a lot of exchanges in real life exchange where you can exchange tether to Turkish lira and stuff. So I discovered that and I realized, okay, how does this thing work? And I started becoming more and more into it. And I started developing smart contracts on some other chains. All the time I was very interested in Bitcoin. But I couldn't build anything on Bitcoin because the tooling was not enough. The script wasn't expressible enough. So I built smart contracts on other chains, but I was always looking into Bitcoin. And then I think after a year that I started smart contract development, I discovered zk technology. And it was the time that also my co-founders and I co-founded our company Chainway Labs more than 2 years ago. So initially we built some products, we built on zk space, we invented something called proof of innocence, then Vitalik wrote a paper about it. And then we basically learned a lot of things about zk and built actual real life implementations of zk, not just a theory. And then last year with Ordinals, actually, we got more and more into Bitcoin development and realized we can actually build some useful things here. And this was how Citrea idea basically born. We can actually build DeFi on Bitcoin by using zk and the block space, which is enabled by inscriptions. And that idea eventually evolved and became Citrea. Then later we just expanded our team in that direction. And right now we have been building it for almost one and a half year.
Oh, nice. It was quite an extensive journey for starting off with smart contracts and then looking into zk and then ordinals. So you had quite an extensive experience there. Yeah, good to hear. I'm wondering, you mentioned that at that time you were always interested in Bitcoin, but there were certain limitations, especially on the scripting side.
Yeah.
I'm wondering if you can speak about how you see the Bitcoin ecosystem evolving in the next few years and where you see zk's role in it.
Yeah, I gave a lot of talks about it. This actually the history of applications on Bitcoin. Initially, people started building applications on Bitcoin since the introduction of Bitcoin. Basically, they built Satoshi dice, they built colored coins. It was all applications, not focusing on the monetary aspect of Bitcoin, but security of Bitcoin. And it's the OG blockchain, so everyone wants to build something on it. But with Ordinals, we see a new, I think, developer wave coming to Bitcoin, which is very important because all those years people are focused so much on Lightning and the core development stuff that they just simply didn't look any applications that Bitcoin can be utilized. And as a result of that, there are many blockchains born. And today Bitcoin is, I think, only 60% dominance in the crypto market, which previously it was 100%. And I think people want to use those applications, so they cannot use Bitcoin, so they went to the other blockchains. But with Ordinals, we see a new wave of developers coming to Bitcoin trying to fix some stuff. And we were also one of them. And realized we can use our knowledge in zk to build these applications on Bitcoin, which may help make Bitcoin maybe 100% use the only blockchain again in the world, because Bitcoin is the best monetary asset that we have. Bitcoin blockchain is the most secure blockchain that we have. So why not just build applications on it? But previous Ordinals, the tooling was not enough for that because no one looked into it, no one spent effort to make the developer experience better. But with Ordinals, we see some applications trying to get built, people build token standards, people build order book exchange for it, people build marketplaces for them. But the thing is, it's still very bad UX and UX. For every single application, you need to build your own indexer, own interface, own even wallet maybe. But now we are just like bringing an existing virtual machine to Bitcoin EVM by using zk, so that we can reuse all the tooling that's built for Ethereum and other chains, and that just like maybe makes the UX and UX 100 times better than building on the L1, and it also makes use of L1 very efficiently compared to the just L1 native protocols. So yeah, I think it's just evolving and evolving, and through Citrea you can just bring, like I said, all the tooling that's been developed on Ethereum to Bitcoin, and this just will increase all the experience for everyone in Bitcoin.
Nice, and I really like how you're not really trying to develop new tooling from the ground up, but instead you're already using what's already existing out there, what developers are already familiar with, and that really helps, I think, with the adoption, general adoption there. Also wondering if you could talk a little bit more about the application side. So you mentioned that you're excited to see some new applications being built with the assistance of zk onto Bitcoin. What are some applications that you're very excited about? Yeah,
so today, even like the most, let's say, hardcore Bitcoiners, what they do is they hold fiat, like USD, and then they buy Bitcoin using centralized exchange, and most of the time they just like don't get onboarded to the blockchain. They just keep their holdings in centralized exchange or custodial solutions. And that's a result of you cannot buy Bitcoin trustlessly on BTC, not Bitcoin network, and the holding Bitcoin experience is not so great. You have to open that ugly wallet, you have to set up your seed phrase. It's too much work for someone to do. But what we are building can enable a lot of stuff. The first is obviously decentralized exchanges. Now you don't have to trust the exchange to execute your order. You can just execute yourself on blockchain. The second is you can hold actually Bitcoin-backed stablecoin instead of holding USD. And then you can just hold that, and you can buy Bitcoin whenever you want without asking any permissions, without doing KYC. It's just in a single click using blockchain. And even after buying Bitcoin, you are holding Bitcoin with your own keys, which is much more important than just like setting up a custodial account on centralized exchange. And we can improve that non-custodial user experience because we have different curves that we can use in EVM, so that we can build, let's say, very easy to build hardware secured wallets, so you don't have to remember your seed phrase. With account abstraction, we can build email logins using passkeys, for example. So a lot of stuff can be built, but the most exciting things, I think, the first is the Bitcoin-backed stablecoin. The second is probably Bitcoin-backed loans, because Bitcoin as a collateral is very precious, and it's right now only can be utilized using centralized tools. I think that's a very big market. And maybe the third thing is also the prediction markets that's intended to be actually built on Bitcoin maybe 10 years before. But now it's built on Ethereum because the tooling was not enough back then, but now we can actually build this. So these are, I think, the most probably widespread used will be used in the future, the use cases for Bitcoin.
Yeah, and I'm personally very excited about the idea for Bitcoin-based collateral. I think that's a huge value proposition there. So very exciting time that we're in right now. And you were also talking a bit about kind of the proposition behind these non-custodial solutions. I'm wondering if you can elaborate more on that for anyone who's not too familiar in the audience, the importance of these non-custodial solutions, and also some of the use cases that are enabled from it. Yeah,
I think like Bitcoin is pushed through custodial and centralized solutions because the experience was not that good. So if you are, let's say, newbie and you want to use Bitcoin in payments, you cannot set up a Lightning node because it's very hard to set up, and you have to manage your liquidity. You have to hold your own keys with seed phrases, and maybe you have more than one key. So the experience gets worse and worse over the years. So people just shifted to use custodial Lightning wallets or custodial Bitcoin wallets because you just log in with your email, and you see your Bitcoin. But that Bitcoin is actually not yours, right? It's held in some other server, some other custody. You just see the representation of Bitcoin, which was never the intended use case by Satoshi. The paper basically says this is a peer-to-peer electronic cash without a centralized financial institution. But what we ended up is we have something called BTC, but it is just the name. How we are using it is fully centralized and custodial. So we want to change it. And how we can change it is just improving the experience for developers to build better tools, which we already do, and improving the user experience, which will be a result of the developer experience, basically. So in Ethereum land, people build very good solutions to embed, let's say, your seed phrases into your Apple secure enclave, which you already trust for your old stuff that's, let's say, natively built on Apple iPhone. But now you can actually sign transactions using that secure enclave as well, so that you don't have to remember a seed phrase. And you can set up social recovery because you have something called zk email, where you can prove that you got an email to the blockchain, actually. So this stuff basically made self-custody better. And Bitcoiners and the Bitcoin world is not aware of any of this. Like, they don't know these technologies exist because it's not applicable directly on the L1. But what we try to do is just bring all the technologies to Citrea so that we can offer people very easy to set up payments and self-custody tools by still holding your own keys.
Mm-hmm. Yeah, nice. And I'm just wondering also on the scalability side, I'm wondering if you can maybe speak about some of the challenges that come with scalability proposals, like we've seen some with sidechains especially, and also maybe you could also touch on the differences between like sidechains and rollups in terms of the scalability.
Yeah. So with rollups, you can get, in terms of scalability, you can have, for example, very fast block times, because you can just, like, you don't need that big consensus as Bitcoin. You don't need proof of work. Maybe you can just generate the blocks using some proof of authority mechanism, because you don't hand over your keys to still the sequencer. It's still proved with ZK, so you are still secure, but you just don't have to rotate the block builder role. So you can get a scalability benefit, but compared to sidechains, rollups are inherently not as scalable as sidechains, because the sidechain is just another blockchain which is not connected to Bitcoin at all. It is its own blockchain with its own validator set. Even though it uses Bitcoin as a staking asset or some other asset, it's a separate blockchain. And the dilemma here is rollups can have a trust minimized bridge to Bitcoin, but sidechains, in any case, they cannot have a trust minimized bridge to Bitcoin. So they don't actually get benefit of BTC as asset, and they don't get the benefit of Bitcoin security, the double spend security, the censorship resistance. They don't get any of this. It's just another blockchain that breeds some form of Bitcoin and call it Bitcoin, but it's actually just probably like a multisig based bridge, where you have honest majority assumption. And most people think like it's extremely scalable, so it is better than rollups, but the trust assumption is very similar to while you are moving to a centralized exchange, which keys are distributed in couple servers maybe. So that's why we choose to build a rollup, because we realize people actually want to use Bitcoin security with ordinals. Like, they don't, even though BRC20s are meme coins, they wanted them to be on Bitcoin, not on some other sidechain. So that's why we built rollups, because rollup is just identical to the underlying blockchain. The only thing is you get you can use different VMs, you can use different block times, and you can build a trust minimized bridge between the L1 and the rollup. So I think that's why we already choose to build a rollup, and that's probably the most important thing, that as a scalable solution that you should get is the trust minimized bridge plus the double spend security of the Bitcoin.
So there's trade-offs to exist in both. Like for sidechains, there's that scalability portion, that's their main value proposition, but you can't inherit the kind of native security that comes with Bitcoin. I see, yeah. And just on the topic of rollups, can you discuss about some of the differences between building a zk rollup on Ethereum versus on Bitcoin? Are there any sorts of differences in the design considerations that people building on need to consider? Yeah,
so we are building this for like months, like more than a year. And if we were building this on Ethereum, we could just like use any rollup as a service provider and just launch a rollup. But on Bitcoin, you have to have different considerations. Like, using Bitcoin SDA is very different than using Ethereum SDA, and also the proof verification is probably the main challenge. In order to verify a ZK proof on Bitcoin, you have to use something like BitVM, the core ID of BitVM basically. And in order to make it build, you have to embed your ZK proofs into Bitcoin, which is one aspect of the rollup. The second, you have to be able to aggregate these proofs into a single proof. The third is you have to be built like just Bitcoin Lite clients that you can prove on BitVM. And you also have to build all the rollup stack, like the sequencer, the VM, the full nodes, the prover. So it's too much work compared to the Ethereum zkRollups because the tooling is already ready. We are using, like most of them, we are using Rust EVM implementation. We don't have our own EVM implementation, but we are building our sequencer, full node, and prover from scratch, as well as we are contributing to the BitVM open source code base, basically. So yeah, it's very different. It's probably much more harder because it's just fresh. Like there's no rollup running on mainnet, Bitcoin mainnet. We are the only ones running on testnet with a fully open source code base. So I think, yeah, it's hard to build, but it's worth it probably.
Mm-hmm. Yeah, definitely. And also wondering, you mentioned a bit about the DA aspect. I'm wondering, just hearing your thoughts on why you chose, or Citrea chose, Bitcoin specifically as the DA and also settlement layers, and how that maybe differs from some other kinds of alternative choices.
Yeah, it's the same thing with sidechains and rollup thing actually. Their main difference is sidechain uses its own DA layer, and rollup uses the underlying blockchain as the DA layer, which is Bitcoin. And that's actually the only way that you can get all the security properties like the double spend resistance, the reorg resistance, censorship resistance, and trust minimize breach. If we were to use another blockchain as our DA layer, we will probably like be extremely scalable, but we still give away our main properties. Like we cannot build a trust minimize Bitcoin bridge because we have another DA layer, which also have a trust assumption. And we cannot maybe build a censorship resistance layer because we cannot enforce forced transactions on Bitcoin. So there are a lot of trust assumptions that's added by using another DA layer. And people don't want that because, like I said, it's the origin point of Citrea is people want to use Bitcoin because they are issuing meme coins, they want to do trades, and they don't want to do that on a Bitcoin sidechain or another DA layer. They want to use it on Bitcoin because it's the only way to get Bitcoin security. And that's why we are using Bitcoin as DA, even though it's much less scalable than other DA layers.
And also, I know that for Citrea specifically, you guys really focus on giving developers that kind of choice. So for, say, devs who want to prioritize low costs but maybe don't mind as much on the DA guarantees, are there any sort of other like alternative options that they can take specifically on Citrea?
Yeah. So initially, from now and the early like days of mainnet, they can build layer 2s on Citrea, which is like layer 3s on Bitcoin basically. Because like on Ethereum, we have now rollups that uses Avail DA or Celestia DA or Eigen DA, and you can just use the same infrastructure on Citrea as well. You can build Validiums and Optimiums that use alternative DA layers, but settle on Citrea, and through Citrea they will settle on Bitcoin as well. So we give that option to developers by default. If their application requires, let's say, sub-cent transactions, like it's a gaming app that they want to use Bitcoin as the in-game asset, then they can build it with alternative DA layer without asking any permission. They can just deploy their rollup on Citrea by using other DA layers, so it will be extremely scalable and cheap, but it will add some minimal trust assumptions on top of, which probably like some of the use cases are fit for it. That's the short-term goal, and the long-term goal is to introduce a volition model, which basically shards your blockchain into two. One is using your own DA layer, and the second is using Bitcoin as DA layer. So developers can choose where to deploy their applications, but these two are still interoperable. You can just do all the sync calls between them, unlike an L3. So that's the long-term goal, but that also requires another engineering resource to be spent. So it's not our priority for mainnet, but after mainnet, we definitely want to implement this feature.
Got it. And I really like how you guys are providing devs with that kind of choice based on their needs. So in the future, we'll see those volition models. And then you mentioned that, for example, some applications like gaming solutions, they may want to prioritize more on that speed and low cost. So providing them with those different options is pretty valuable. So really appreciate that. I also wanted to ask you a bit more about the kind of interplay between the fraud and validity proofs on Citrea. So I'm wondering, like, if you could talk a bit about the benefits behind settling these ZK proofs optimistically, and how that interplay between optimistic and ZK comes forward.
Yeah, so there are two aspects while building a rollup you need to consider. One is like how full nodes get confirmation, And the second is how Bitcoin gets confirmation, the bridge gets confirmation basically. For full nodes, we are already embedding our zk proofs into Bitcoin, so they can just track the Bitcoin blocks and they can verify all the rollup. So from their perspective, they just see the zk proof, immediately verify without any optimistic challenge response, and they just get confirmation. But for the bridge, Bitcoin has limitations, so you cannot verify zk proof on Bitcoin in a single block. So you have to divide that execution into chunks. And even though you divide, it's not practical to execute every chunk because it will probably take maybe like 100 or 200 full blocks, which is not practical and it's extremely costly. But instead, what we can do is we can settle zk proofs using challenge response mechanism. So we already have zk proofs on the DA layer, and off-chain we can aggregate these proofs and say that this is the bridge checkpoint proof. And if someone disagrees, they can always go on chain without asking permission, and they can put a fraud proof to say that, okay, I'm challenging you. Let's just execute this part of the zk verifier because I believe it's incorrect. And the operator executes that part on chain, and if it is incorrect, the operator gets slashed, so the bridge is protected. If it is correct, then the verifier gets slashed because it tries to, let's say, attack the bridge basically. So that's how we incorporate all the optimistic challenge response on Bitcoin to make bridge get confirmation. But for full node, it's still full zk without any optimistic mechanism behind it.
Got it. And yeah, I really like how you guys are kind of incorporating both into there. So in the case where there's a challenge, you can also have a fraud proof be applied in addition to that zk proof as well.
Yeah, we are just doing our best to make everything work very securely.
Yes.
Just connecting all the dots to make it work, because we can just wait for some dedicated opcode on Bitcoin to get enabled so that we can just directly settle zk proofs on Bitcoin. But that's not convincing enough for Bitcoiners to activate that opcode. So what we want to do is first just deploy this as a trust minimized version with this optimistic mechanism and show them we can actually have a use case for it. People are using it, there are applications, there are better UX, there are better DevX. And if you want to make it trustless, let's just enable an opcode to make it fully trustless and remove the optimistic part. But that will hopefully be in the future.
Yeah, very much looking forward to that. And just on this topic of proof generation, I'm wondering if you can speak a bit about the proof generation process specifically on Citrea. And then I know you guys are also incorporating both the light client proofs as well as the batch proofs. So I'm wondering what was the intention of incorporating both and the differences if, say, you were to just incorporate light client versus just incorporating those batch proofs.
Yeah, so for batch proofs, it is basically for all the blocks we generate, we get an interval of the blocks and generate a proof for them, which is called batch proof. And that proofs are inscribed on Bitcoin, and that's actually how full nodes get confirmation over. So they just look into the proof and verify the proof. That's the batch proof. But later we have this bridge that we also need to convince about, the Citrea proofs. And that bridge cannot verify, let's say, 1,000 of batch proofs because it only has a single proof verifier script. So what we do is we aggregate these batch proofs together into a light client proof, which is basically the same with batch proofs in terms of security guarantee, but it just collects all the batch proofs into one so that you get easy verifiability on everywhere, including Bitcoin itself. So that light client proof is eventually also wrapped into some other proof, but that's the core of the other proof. So the light client proof gets verified in Bitcoin using BitVM. That's how bridge get attestation of the rollup basically without trusting anyone. So for these two we use Starks basically. Right now we have RISC-0 implementations running on testnet, but we want to do multi-proving. So we integrated SP1 as well. It's not live yet, but the implementation is done. So for batch proofs, we will have two different proofs generated. One is by RISC-0, the other by using SP1. But eventually those proofs also wrapped into Snark using their own Stark to Snark circuits to make it even smaller to put on Bitcoin.
So you're incorporating that multi-prover approach from there. Okay, nice. And also wondering on the topic of Clementine, if you can talk a bit. I saw that you guys are using a two-way peg mechanism there So wondering if you could speak a bit about how that works, and then also the core components that are involved within Clementine.
Yeah, that's the whole bridge thing is called Clementine, and it includes first the light client proof verification through BitVM. We are one of the core developers of BitVM. It's called BitVM Alliance, the group of core developers that's contributing to BitVM. And with that, we get this light client proof verification on Bitcoin. But that's not enough to build a bridge. You have to have all the UTXO coordinations, the operator set, the verifier set. You have to have a set of smart contracts on Citrea that recognize these operators and verifiers so that you can incorporate minting CBTC, burning CBTC. So the whole mechanism is called Clementine. But the core of it is BitVM, obviously. And outside of it, we have some our own contributions, like a custom light client implementation for Bitcoin, a different deposits mechanism, a different withdrawal mechanism, and also like a set of EVM contracts to facilitate this minting and burning mechanism.
I see. And also, just on the topic of your sequencer architecture, I know that you guys eventually have plans to decentralize it. So I'm wondering if you can speak about some of the implications and benefits for decentralizing the sequencer set, or any sorts of even like limitations or drawbacks to consider.
So even with centralized sequencer, as long as you have like forced transactions, then you can just transact whichever you want. But forced transactions has to go through Bitcoin, which may end up being expensive at some times. So eventually what we want to have a decentralized sequencer, so we can just reduce the amount of transaction that needs to go through Bitcoin, because it will provide a better UX for users who wants to transact and think that they get censored. So the main thing about decentralized sequencer is first you get this better censorship resistance. Still you have Bitcoin, but as long as you have another layer so that people can do cheap forced transactions using decentralized sequencer. The second is obviously liveness. The single sequencer can, let's say, have a bug and it can go down, but decentralized sequencer, it's unlikely all the sequencer has the same bug. So that's also another important thing. But it also needs another engineering effort, which probably will delay our mainnet by maybe a year even. So we don't want to do that. We just want to launch with it this way because it's still trust minimized. You still have zk proofs. Maybe liveness is a bit worse than having a decentralized sequencer, but we can just launch this way, and then after mainnet we will improve it with incorporating decentralized sequencer mechanism. But yeah, it also has its own limitations. One is the engineering overhead. The second is you have to make sure that your proofs are fully correct and sound, all get audited, because now you don't control the sequencer. And the other thing is the block times. Right now we have 2-second block times, but maybe if we had we won't probably, but if we had thousands of decentralized sequencers, then having a 2-second block time is very hard. So that's why we are just trying to optimize everything, but we are starting with a single sequencer.
Got it. So there's some advantages just on the liveness and then also censorship resistance, but then there's also that overhead and even block times that you need to consider. Yeah, I see. And also wondering about kind of your thoughts on achieving trustless settlement with Bitcoin as well. So how do you see this being implemented in the future, and how that kind of differs from our current standard for trust minimized settlement? What will this bring?
Yeah, that fully depends on Bitcoin consensus. It is not something that's already available and we are not doing it. It needs a new opcode change, a new soft fork to Bitcoin. So a couple options there. One is OPCAT. If we get OPCAT, then we can implement a start verifier on Bitcoin, and we can implement covenants, which enforce a transaction to go to somewhere. And basically by using these two, we can have a fully trustless rollup built on Bitcoin. And the second is a dedicated opzkp opcode, maybe something like that, so that you can just verify without trying to construct all the verifier scripts. But these two, one is the opcat is already proposed, the other is still people are talking, but there is no BIP for it. And Bitcoin consensus takes obviously time. We even don't know whether these opcodes will get activated or not, but they're in discussion. And if the community, all of the Bitcoin community, has a rough consensus to activate, let's say, OPCAT, then we can immediately switch to a trustless rollup construction, which is obviously the ideal and what I want personally. But it's right now not possible. So instead of stuck on that, we're just trying to build in a trust minimized way and then later we can upgrade to be a fully trustless.
Got it. And just as a last question before we close today's session, I'm wondering if you have any sort of advice that you want to give to the audience, or any announcements that you'd like to make on Citria's behalf.
I think, for announcements, we recently announced our Series A, and as a part of it, we launched something called Citrea Origins. Citrea Origins is a set of basically a community of elite developers that's building applications on Citrea. It's not like, let's say, a group, the Discord group or Telegram chat. It's actually an incubation program that we provide a lot of support to these teams. It's like not just the funding or other things, but we just help them to build their own startup like we did. Help them get the funding, help them build the product roadmap, build their brands, go to market, growth, community building, everything that we learned along the way. We're just trying to transmit all the information to them. So it's a very neat, very, I say, good designed incubation program. If you want to build a Bitcoin application, just make sure that you are following Citrea Origins and apply to it with your ideas, so that we can talk with you, identify the problem, help with your solution, and maybe even support you along the way. So probably that's my main focus at Citrea right now, helping developers. There are already a couple of them that's building Bitcoin native applications using Citrea. So its Twitter is Citrea Origins, basically. So you can just visit there and get all the information about how we help developers, where we will be next as in-person events. So yeah, I think that's the major announcement.
Yeah, sounds good. And I really like how you guys are really focused on developers, so providing that good developer experience with the tooling, and then also support as well. So I think that's pretty valuable. And yeah, thank you so much, Orkun, for joining us. Really enjoyed hearing about what you guys are currently building on Citrea, and also the advancements that we'll see in Bitcoin in the next few years. Pretty exciting times that lie ahead of us. So really appreciate you for being here, and thank you for all your insights.
Yeah, thank you for great questions.
Yeah, thank you so much.